Hello again, this is Mark Summers from Summers Technical Services. We're going to move into some manufacturing engineering topics and learn some basic skills about manual milling. So we've got our part we designed in SolidWorks, and it's got some counterbore holes, a couple of different size drilled holes, and an overall shape. It's all square rectilinear part. And so we're going to turn this part model, and well, we got the model here, and then we've got the drawing. So let's toggle over to the drawing. And so this is the manufacturing drawing we're going to use to make this part. So it's got all the dimensions we need, all the notes for the materials, and sizes of the holes, location of the holes. And so we're going to fabricate this part based on these dimensional drawing. And so let's walk over to our raw material we're going to be using, and here it is right here. And so this is a cast aluminum block, and it's obviously not ready for prime time. We've got some work to do. And so the first thing we're going to do is square this part up. When I say square it up, we need to have all 6 faces parallel and or perpendicular, parallel or perpendicular to one another. Because when we start drilling these holes, we need to make sure we've got square faces so that when we dimension off those square faces, doesn't matter which face we're coming off of, they're all going to be parallel and perpendicular to one another. And so I'll mark these faces on this part first. But before we get started, let's take a look at this material here. And so this one's already been machined. Let's look at this other part over here. This one has got, this is as it came out of the casting process, out of the mold. And you can see on this face here, this has got some dimple here. This is reduced down here. This is shrinkage. This is what happens when you make a cast part. You're going to always get shrinkage, and this thing is below the surface in the middle there, because this hot molten metal, when it cools, it's going to shrink, and you're going to always get this feature on your cast parts. And so we have ways of minimizing that shrinkage, and we'll learn more about that when we talk about our casting processes that we'll learn in future videos. So what I've done is label these faces in the order we're going to machine them. And so the A surface is this first surface here. We want to make sure we machine this flat so that we get rid of this dimple here. And then I've labeled the opposite side A prime. And you can see this has already been machined, it looks like. But this will be parallel when we get through to this side over here. And then I'm going to have the next largest surface area side is going to be this B side here. We're going to machine this perpendicular to our A surface on the milling machine. And then eventually we're going to take this other side over here that I call B prime, and that's going to be parallel to the B surface. And then after we do A and B, and those are perpendicular to one another, we're going to move over to the smallest edge, C. We're going to machine C to be perpendicular to both A and B. And then once we do that, we're going to machine the C prime side to be parallel to the C side. And again, these all have to be parallel and or perpendicular to one another as we go through this 6-sided squaring process, because otherwise we're not going to be able to locate our holes with a flip. So this is a very critical part of the machining process. And when we start that here in a little bit, we'll make sure that's done correctly. All right, so now you see the part that we're going to be machining. Let's figure out the tooling we're going to use to make all this magic happen. And so the first tool we're going to use is a face mill. And the bulk of this thing is just holding these inserts. And let's lay this thing over carefully. I'm going to break this thing. Here we go. So the action is happening on these inserts. And so these are cemented carbide inserts. They get screwed into the tool, and this is where the action is happening on the machining. And so for our calculations we've done in class, I believe this is a 4-inch diameter face mill, and so big D would be 4, and the number of teeth would be what? 1, 2, 3, 4, 5, 6, 7. So little n would be 7, because there's 7 teeth on here. And these inserts, these are extremely stiff, they're extremely strong, but they're also extremely brittle. So you have to be very careful with this thing to make sure you don't drop it, because these things will shatter easily. And when these inserts get worn, when the nose radius gets bigger and bigger and bigger, at some point we're going to want to replace this thing. But since these things have 4 sides, we'll be able to unscrew these when they get worn out, rotate it 90 degrees, and then use it on these other sides. We can do that on all 4 sides before we have to replace the inserts. So that's the face mill, and again I'll give you a data sheet on that as we do our calculations. The next thing we're going to do is use a couple of different twist drills, and these are HSS steel twist drills, the 2 different size holes that we're going to drill. And I also give you data sheets for them, so you'll know things like the recommended spindle speed and the plunge rate, so that we don't overload the machine when we make our holes. And then the last tool we're going to use is this, oops, let's spin it around here. Looks like it's got a part number on there. That might be useful at some point. So this is a flat end mill, 3/4 inch diameter flat end mill. And so let's go take a look at this, and it's similar to the other tools. This is extremely stiff, extremely strong, but it's extremely brittle. So it's a flat end mill. The end is flat. It's got 4 flutes, so there's 4 cutting points. And again, the flute is to help when as a tool is cutting, the material's got to have a place to go because it can't live inside the hole that we're drilling. And so the flute allows the material to wind its way out of the workpiece in a way that we can get it away from the part we're machining. So we'll use this to do all 4 counterbores. All 4 counterbores are 3-inch diameter, so we can use this one tool to do all 4 counterbores. All right, so maybe that's a good place to stop discussing the part itself, the cast part. We start with squaring operation, and where we get the dimensions from the CAD drawing, the face marking so we know the order we're going to do. We're going to make A flat to itself. We're going to make B perpendicular to A. We're going to make C perpendicular to A and B. And then we're going to go back and make B prime parallel to B, and then C prime parallel to C, and then we'll have our squared part. Then we'll move in and use the drills and the counterboard to do those holes. So let's quit talking about doing stuff and go over to the machine shop and actually make this part. So stay tuned for the next video.